All right, we are now going to enter the Earth. As you enter the Earth, the pressure and the temperature are both going to increase. The pressure increases just because of the weight of the overlying rock, so pushes down on the rock beneath it. The temperature increases as depth increases. This is because there is heat on the interior of the Earth. Remember that the Earth was very hot in the very beginning when all those planetesimals hit each other and the Earth heated up, and through differentiation, the Earth melted. There's still some of that heat left over, and there's also heat generated from the decay of unstable isotopes, radioactive decay in the interior of the Earth. So there's plenty of heat inside the Earth to heat it up. So as you go down into the Earth, it warms up. That rate of increase in temperature is called the geothermal gradient. That's different places on Earth. It's going to vary. So sometimes it's pretty high, 50 degrees Celsius per kilometer, or it can be low, 15 degrees Celsius per kilometer. We haven't talked about plate tectonics yet, but the different geothermal gradients depend on the plate tectonic setting. You can imagine there's a low geothermal gradient in the interior of, say, North America, whereas a place where there's volcanoes, you would have a higher geothermal gradient. In the early days of science and observation, they didn't have fancy equipment, so they were just trying to figure out and explain what they saw on the Earth's surface, and how to explain in processes on the interior of the Earth. Like, where does lava come from? Why are there gems and minerals in this place and they're not in this place? Why does water just come up out of the Earth? And what are earthquakes? What's happening? What causes earthquakes? Most of those guesses were pretty wrong. And it wasn't until later that scientists discovered ways to explain that list of phenomenon that were happening in the Earth's inside the Earth and had a surface expression. It used to be thought that there were big open caverns in the interior of the Earth, and we know that sure there are some caves at the Earth's surface, but they don't go very deep. Okay. All right. A key to understanding the interior of the Earth is understanding the density. And we can, of course, get a rock from the Earth's surface, crush it up, and figure out the density of that rock. But once we start looking at the interior, we couldn't really get there. So scientists came up with different ways to set up an apparatus like the one here, a surveying instrument, to figure out densities. They had a surveying instrument out, and they realized the plumb bob there, it was being pulled towards the mountain. So there's a gravitational pull of the mountain, as and also a gravitational pull of the Earth. So they started doing different density experiments with the surface of the Earth and the whole Earth. They came to realize that sure, there was a density of rocks at the surface, but as you get there, there was more dense rocks of the whole Earth. And so where were those dense rocks? So the suggestion was the density must increase with depth, and that came to be true. So they were doing density tests with the plumb bobs, and also looking at meteorites and looking at the density of meteorites. In 1896, Emil Wiechert contributed that the Earth must be really metal on the inside, and that turned out to be true. That the iron nickel core is metal, and so that was a hypothesis, and that started bringing about the idea of differentiation, where the heavy atoms sunk to the interior of the Earth during differentiation. We know he was right. His ideas led to that model here with the egg and the interior yolk being the core, the white being the mantle, and the shell of the egg being the crust. So that's a hard boiled egg. Nowadays, we know a lot more about the Earth's interior, and a part of that is attributed to seismic waves. When an earthquake occurs, the seismic waves radiate out away from the focus of that earthquake, and the waves travel different velocities through different types of material, different densities of material. They also travel differently through solids versus liquids, and the seismic waves um, deflecting and changing through the earth after an earthquake is how we really started to understand the interior of the earth.